we'll start learn the section 5, chapter 7. In this section, we'll learn the attitudes. Attitudes, in the previous section, we learned all the media. Three medias, they intersect each other. They concurrent. One point, we call that centroid, right? So today we'll learn that all three attitudes also will concurrent. Then now let's start from here. See example. Problem 7.22. Say in this problem, we'll prove that the lines containing the attitude of any triangle are concurrent. So that means the three attitudes intersect at one common point. This is a pretty slick proof. Before trying it, you might want to review what we learned about the medial triangle in section 7.4 here. Now let's keep reading this. See this diagram show that AD and BE and CF of that's attitudes of this triangle ABC on set BC and AC and AB, right? So now we draw a line through point A parallel with BC. Draw a line through A parallel with BC. And a line through B parallel with AC. And a line through C parallel with AB. Then these three lines will intercept at another 3 points. We'll see that later, okay? The intersections of these three lines form another triangle. Call that triangle we called JKL, with A on KL and B on JL. So first, now they ask you show the triangle CAK congruent with ACB. CAK congruent with ACB. Okay, now let's go this picture. This picture is here. Okay, say this is a triangle ABC. We draw a parallel line KL parallel with BC, okay, through this point A. Then we draw a parallel line LJ parallel with AC, and another line parallel with AB, that's KJ. Then these three lines intersect at KLJ. Now here we try to prove triangle CAK congruent with ACB. So ACB congruent with AKC. So how to prove these two triangles are congruent? This is very easy, right? So first, now let's see. Because what we draw KJ pass through C is parallel with AB, right? So that means this angle equals this angle, right? This is called alternative interior angles. So the angle KCA equals CAB, right? Then we also have this angle equals this angle. Why? Because the line we draw pass through A, this KL parallel with BC. So this angle with this angle also called alternative interior angles, right? So then these two triangles share the side AC. So then we can use theorem we learned that's called ASA to prove these two triangles are congruent. Now I can write down here, because KJ parallel with AB. From this one, we can get angle KCA equals CAB. Okay, this one equals this, because this line parallel with AB. These two angles are alternative interior angles. Then from KL parallel with BC, then we can get angle KAC equals angle ACB, right? This angle equals this one. Then these two triangles share side AC. AC equals AC. Then you combine these three piece of information together. You use ASA theorem. We can get a triangle KAC congruent with triangle ABC, right? So we proved this. This is a B. Show that CAK congruent with ACB. We proved this, right? We use angle side angle theorem. Now let's see C. C, they ask you use part B and similar congruence to prove that A, B, and C are all the middle point of. They ask you prove point A, point B, point C are all the middle point of KL, LJ, and KJ. Okay, so how to prove this? You know, very easy. We already proved the triangle ACK, this one, this triangle, congruent with triangle ACB. We already proved this one congruent with this. So that means that we have this side. You see, this side congruent with this side, right? So this is opposite of this angle, side of opposite this angle. This one is opposite of this angle. They should equal, right? Then this side should equal with this side, right? They share this side. Now let's see how we can prove A is middle point of KL. So to do that, you need to prove AB equals half of KL. You know, we already proved that this triangle is congruent with this one. Now, we also can prove this one congruent with this one. Congruent with this one. You know why? Now, let's see here. How to prove ACB congruent with BCJ. See, same reason when you draw the line LJ parallel with AC, you will get this angle equals this angle. There's also alternative interior angles, right? Then you have AB parallel with KJ. Then you have this angle equals this angle. Right? Then these two triangles share the side BC. Then we still can use ASA, prove this triangle congruent with this one. So then you can also get AB will equals CJ. So AB also equals KC based on the congruent of this triangle with this. So that means AB equals half of KJ, because KC equals AB, CJ also equals AB. Then that means AB equals half of KJ. Okay? Then you can use triangle KBL similar with triangle LKJ. You know, because you have this line AB parallel with KJ, then you have this angle will equal this angle. This is called corresponding angles, right? If you have two lines parallel each other, then you have this angle equal this angle. Then this angle will equal this angle. Then you can use AA similarity theorem, got this triangle congruent with this one. Then this one over this one will equal this side over this side. We already get AB equals half of KJ. That means AB over KJ equals 1/2. That means KLA over LK also equals 1/2. That means A is middle point of KL, right? So now let's say first I like show you how we prove the triangle ACB also congruent with triangle BCJ. Okay, say first, because we can still write here KJ parallel with AB. From this you can get this angle equals this angle, right? So that means angle JCB equals angle ABC. This is the first angle, first pair, right? Second one, we can get LJ right here. LJ parallel with AC. From this, you can get this angle equals this angle, because this one parallel with this. Then get the angle CBJ equals angle ACB. Then these two triangles share the side BC. So BC congruent with BC. Then combine these three pieces of information together, use ASA theorem, you can get triangle ABC congruent with triangle JCB, right? By this one, after you got their congruent, then you can get AB will equals CJ, right? Because AB, that's opposite of this angle, and the CJ, that's opposite of this angle. these two angles are congruent. That means these two sides also congruent. So that means this one equals this. From triangle AKC congruent with ACB, we already proved AB also equals KC, right? So then you combine AB equals KC. From combine these two together, we can get AB equals half of KJ, right? Or you can set KJ, this one equals twice of AB. Then, because AB parallel with KJ, from this one, actually you can immediately get these two triangles are similar. Triangle LAB similar with triangle LKJ. Just because this line parallel with this, then you can immediately get this triangle LAB similar with triangle LKJ. Because this parallel line immediately gives you the two corresponding angles are congruent. Then use AA similarity theorem, you can get these two triangles are similar. From this similar, then you can get corresponding side of ratio, there should be same. AB over KJ will equals AL or LA over KL. This LA over KL. So this one also equals 1/2. So by this way, that means A is a middle point. A is the middle point of KL, right? Because AL equals half of KL. So that means A is the middle point. Okay? Same way, because AC parallel with LJ, then you can get KL, KC over KJ also equals 1/2. So that means C is middle point of KJ. You can also get B because AB over KJ equals 1/2. This also equals AB over this now LB over LJ. So that means B is also middle point of LJ, right? By this way, we proved A, B, C, these 3 points are exactly the middle point of KL, LJ, and KJ, right? So we proved this. Now, let's see what is the next they ask you to do. Next, that's D. How are the lines AD? How are the lines AD, BE, and CF related to triangle JKL? Okay, so then they ask you how the lines AD, this attitude, BE, this attitude, and CF, this attitude, how this 3 attitude related to the triangle JKL. Okay, think what is this one related to that these bigger triangles? How this one related? Okay, now let's see. This one, for this three vertical, 3 attitude also will be, now let's see, this is a middle point. Now let's see. They draw the lines L, K, KL through this parallel. Yeah, then we got this to that also in the same way from BC. Yeah, middle point. Therefore, triangle ABC it's called the median triangle of JKL. This one it's in the middle of triangle JKL. Then since KL, this one parallel with BC, attitude of AD of triangle ABC is perpendicular to KL. Yeah, because AD perpendicular to BC and BC parallel with KL. So that means AD also perpendicular to KL, right? Then you can also get BE also perpendicular to LJ because BE perpendicular to AC. AC parallel with LJ. Same thing for AD. AD also perpendicular to KL and CF also perpendicular to KJ. Then they perpendicular to all these three sides of the triangles. Then now let's see. Okay, since AD is perpendicular to KL and pass through its middle point. It is perpendicular bisector of KL. Is perpendicular bisector of KL. Similarly, CF also will perpendicular to KJ and also bisect of KJ. Right? Now, it's also the bisector of side. You know, this three attitude also will be the three lines bisector of each side of this big triangle KLJ and also bisector of each side. Okay. Then now let's see lines AD, BE, and CF are concurrent. They are concurrent because they are the perpendicular bisector of the sides triangle JKL. These lines also contains attitude of triangle ABC. So we have proved the lines containing the attitudes of the triangle ABC are concurrent. Okay, now did you understand the logic here? Say in this problem, we try to prove these three attitude AD, BE, CF concurrent. That means we try to prove these three attitude intersect at a common point here, right? To prove that, we now prove this three line AD, BE, and CF actually it's three side bisector of triangle KLJ, right? Because see, AD is perpendicular to BC, then BC parallel with KL, so that means AD also perpendicular to KL, and A is a middle point of KL, so that means AD it's a side bisector of KL, right? Same way, we prove BE is also line bisector of LJ, and CF is also line bisector of KJ. You know, in the first section of this chapter, we proved the line bisector of a triangle concurrent. That means the three lines of line bisector intersect at a common point. By this way, we proved this three attitudes AD, BE, and CF should intersection at a common point. So then that means these three attitudes concurrent. See, this is a wonderful proof. We try to prove these three attitudes concurrent. Then by this way, we convert this one to the three side bisector of another triangle. In the first section of this chapter, we already proved the side bisector of a triangle concurrent. That means they intersect at a common point. Now, this three attitude of triangle ABC actually it's a three side bisector of another triangle KLJ. Therefore, these three attitudes should intersect with a common point. Then that means they are concurrent. So we proved this, right? So now let's go to next problem. So here, how are the lines, say D, how are the lines AD, BE, and CF related to triangle JKL? That means these three lines are the side bisectors of triangle JKL. Then we already proved the sides bisector of a triangle, they should concurrent. Therefore, AD, BE, and CF should concurrent. Then we proved the attitude of triangle ABC are concurrent, right? So we finished this problem. Now let's go to next one. This one said, where do attitude of a right triangle intersect? Inside, outside, or on the triangle? How about an accurate triangle, an obtuse triangle? If necessary, extend the attitude to the point where they all meet. Okay, so now let's see this one. Say, for a right triangle, say this side, it's already it's already the attitude of BC, and AB is already attitude of BC, right? Because these two legs are perpendicular to each other, right? So if you draw an attitude from A to BC, that's overlap with AB. If you draw attitude from C to AB, it's overlap with BC. Then when you draw attitude from B to AC, they will intersect somewhere on this hypotenuse, right? So then that means the concurrent point of the three attitude of a right triangle, it's this point B. That's the intersection point of these two legs, is this B, right? So this is a attitude. AB is attitude, BC is another attitude. And AB and BC already intercept at B. Then another attitude of AC also will pass point B. So then this point B, it's the concurrent point of these three attitudes. So that means the point B, the intersection point of these two legs, are the concurrent intersection point of these three attitudes for right triangle. Now for an acute triangle, say these three attitudes will intersect inside of this triangle. You can see here, right? This point H. For obtuse triangle, say when you draw the attitude from P to RQ, you get this attitude is here, right? But when you draw attitude from P to now let's see, from P to Q. Now is this, if you draw the attitude from R to QP, they will not inside of triangle. They will outside of a triangle. Will go inside here, right? Then if you try to make these two attitudes intersect together, you need extended this attitude to here. This one go to here. Then they will intersect at this H here, right? Then when you draw the attitude from Q to PR, you need extended this RP to here. Then they will intersect this position. Then if you extended this attitude here, they will also intersect with H, will intersect here. So by this way, you can see for obtuse triangle, the concurrent point of these three attitude will outside of this triangle. For acute triangle, the current intersection point of these three attitude will inside of triangle. For right triangle, that will be on the triangle. That's actually, it's a vertex of angle, right angle, right? That's here, that's B. So this is the three cases, right? So we already learned this. Now let's go back. We already figured this problem 7.23, right? Now let's go to 7.24. See, this problem said attitude QZ. QZ is attitude on XY. And XP is attitude on YZ. Intersect with N as shown. Given that angle YXZ, this angle equals 70 degrees, and XZY, this angle equals 45 degrees. Now let's mark this one. This one equals 70 degrees. This one, XZY, this one equals 45 degrees. Then they ask you find each of following. First, find the angle ZXP. ZXP, they ask you find this angle. This one. Okay? What is this angle? Everybody send me the private chat. Actually, this one is very easy. Let's see if you really understand what we are doing here. Say, let's put here. Maybe you can put here. Okay, see, they already give you XZP. This angle, or XZY, equals 45 degrees. Then you can consider, yeah, Emily, you're right. In triangle XPZ, this is the right triangle. This angle P, that's equals 90 degrees. Yeah. May, Sarah, you also got it right. Who else? So that means this angle equals 45 degree. This one equals 45 degree. Why? Because x in triangle XPZ, this angle P equals 90 degree. We already know this angle XZP equals 45 degree. That means the angle PXZ, this also equals 45 degree. So you got a ZXP, this one equals 45 degree. Now let's see XZQ. XZQ, they ask you this angle. Let me change the color. Everybody calculate this. What's this angle? XZQ. This angle equals what? It's also very easy. Send me your answer. If you did not get this one, that means you waste your time. Okay, very good. Emily, you're right. Who else? So here you consider the triangle XQZ. This one also a right triangle. This angle equals 90 degree. They already tell you YXZ. This angle equals 70 degree. That means this angle equals, let's say Daniel also got it right. Very good. That's 20 degree. Yes, this one equals 20 degree. Because this is a right triangle. This angle equals 70 degree. This one equals 70 degree. Therefore, this angle equals 20 degree. Now let's see YXP. YXP. They ask you this angle. I can change the color. Now they ask you this one. YXP. Everybody send me answer for this one. This one is a little bit one-step work. Can you find what is that angle? Now let's see. Actually, because you already got the last two. Yes, let's see. Emily got it right. Who else? Daniel, double check your answer. It's very close. Say here, they ask you this angle. This angle actually equals YXZ. See, this one equals YXZ minus angle ZXP, right? So this one equals 70 degree minus 45 degree. This one should equals 25 degree. Okay. Now they ask you find NYZ. NYZ. Now let me change the color. Let's use this color. They ask you find NYZ. This angle. What is this angle? NYZ. Okay, so everybody try to do this. They say this one has a star there. That means it's hard. So you can try to mark all the angles you can get here. Then that'll be makes the problem is easier. See, we already got this one is 25 degree, right? This one's 25. So then that means this angle, this smaller one will be, this one will equal this. This one will be 65. 65 degree, right? Because this one 25, this is a right triangle. So that means this one need equal 65. This one it's a vertical angle with this. So that means this angle equals 65. Now that's 65. Now let's see what is this angle? Can we find this angle? That one will equals, let's say this one's 65. Now this one's 25. Now this one equals this share. Yeah, this triangle actually is congruent with this one. Right? See, oh no. That's not necessarily congruent because this one not guarantee equals this. So then now let's see. This one will equal sum of this with this. So that means we need to find this angle. Okay. Now let's see. Everybody do this. YZ, continue YZ, hit all. You extended this one to here. Then this YZ will, suppose this one intersect with this with side at A. Then this one will be right angle. So this 70 degree, that means this one will equals 20 degree. This equals 20 degree, that means this angle will equal 70 degree. Right? This 70 degree, now let's say this 70 degree, this 65. So now let's say 70, this angle also will equal 70 degree. 70, then 70 plus 70, that's 140, right? This 65 plus 65, that's 130. Then you add it together, you got 270 minus from 360. This one will give you 90. 90 divided by 2, you got this angle equals 45 degree. So then that means Z, N, Y, oh, they ask you N, Y, Z. Ask you this angle. We already got this one's 45, so that means this angle is also 45. Now let's see if you got this one right. Now let's see. Let's double check. See, when extended here, this angle is 70 degrees. That means this X, Y, A also is 20 degree. 20 degree, then we already get X, Y, P. This angle, should equals, because this angle equals 25. So that means this angle will equal 65. So use 65 minus 20. 65 minus 20, that should be 45. Is everybody got a 45? Nobody got this. Oh my God. Okay. So now let me explain one more time. It looks this one is hard for you. Say you do this way. You extended this line to here because this is the all attitude. Suppose this one will intersect with XZ at A. This also will be a right angle. Because they give you this angle equals 70 degree. This one equals 70 degree. That means this angle will equals 20 degree, right? They ask you N, Y, Z. They ask you what is this angle? This angle will equals XYP minus this angle, 20 degree. So that means we need to find this angle, right? This angle, you know, they give you, we already found this one. Say X, what do we get? Y, XP. YXP, we already got this one, right? So because they give us this 170, they give us XZY. This one is 45. This one is 45. That means this angle, this one is also 45. Because in triangle XPZ, this is the right triangle. This one is 45. That means this one is 45. This one is 45. That means 70 minus 25, 45. Because this angle equals 25 degree. Okay, 25 degree. That means this in triangle XYP, this angle will equals 65 degree. 65 degree minus this 20 degree then give you angle NYZ. So 65 minus 20 degree will equals angle NYZ. This one should equals 45 degree. So that means this angle, question mark, that equals 45 degree. Everybody got it? Okay, so this one's a little bit hard. Okay, now let's go to the last problem in this section. Here said the attitude of triangle ABC meet at point H. At what point do the attitude of triangle ABH meet? How about the attitude of ACH, BCH? Okay, now let's go 25. By this way, I don't need to draw another diagram. Let's go here. See, you have, see this picture. See this one. Okay, everybody see this one. We have triangle ABC here. Their attitude meet at this point H. Then this asks you at what point do the attitudes of ABH meet. Say attitude of ABH, this one CZ is also the attitude of ABH on AB, right? This one is still here. Then the attitude of AH, you draw from B, that will be BX. When you extend it, that will be C. So that means they will intersect at C, right? So the answer for this one, at what point? That's C. At point C, do the attitude of ABH meet? You know, the reason is HZ extended to here. Then when you draw attitude of AH from B, that will be BX. When you extend it, they will intersect with this point C. When you draw the attitude to BH from A, that will be AY. Then you extend it. They also will intersect at point C. So they meet at C. So now let's see, how about ACH? ACH, they will meet at B, right? They will meet at this point, right? Then for BCH, they will meet at A. right? This actually is what we did for the first problem. That problem, to prove the attitude of this triangle concurrent. When you draw the point, draw a line parallel with each side of this triangle, then you got a new triangle, right? So here, if you extended the attitude of this smaller triangle AHB, you will get that this three attitude of triangle will intersect at point C. If you extended the attitude of triangle AHC, they will intersect at point B. If you extended all attitude of triangle BHC, they will meet at point A. Okay? So you can see here clearly, right? So by this way, we finished this section. Then you have this access problem 7.5.1 to 7.5.5. Now let's go to next section. This section called challenge problems. Actually, a lot of proof problems related to the three center point of a triangle, that's a centroid, and introid and outroid. These three center point of a triangle problem, proving problem are very difficult. Now let's see what is the problems we can solve here. Now see, in this section we tackle several challenge problems in which we use what we have learned in this chapter about the special points. Three special points we already learned, okay? Points, lines, and circles of a triangle. You may wish to try your hand at the review problems at the end of the chapter before attempting problems in this section. So now let's see first example here, 7.26. In this problem, our goal is to find the area of ABCD. Given AB equals BC equals 6 and CD equals 3 root 2 and triangle ABC, not triangle, the angle ABC equals 90 degrees, and that is a circle passing through all four vertices A, B, C, D. Then they ask you, A, where is the center O of the circle that passing through all four vertices? B, what is the radius of this circle? C, what kind of triangle OCD? What are the angles in triangle OAD? What is the CDA, angle CAD? Find the area of ABCD. Now let's go to this problem here. Yeah, this is a plot of this problem. Now let's see. In this problem, we have triangle ABC. Okay, ABCD. This is a quadrilateral, right? In this quadrilateral, they give you angle ABC. This one equals 90 degrees. They give you AB equals BC equals 6. Then they also give you CD. This one equals 3 times root 2. And then they said there's a circle pass through these 4 points, right? Now they ask you A, where's the center? Where's the center? Where's the O? The O definitely is on the hypotenuse of triangle ABC. You know why? Here, because this is a right angle. So ABC, AC will be the diameter of this circle. Because this angle is 90 degrees. Then AC is the diameter of the circle O. Then the O will be the middle point of AC. By this way, OC will equals OA, also equals OD. Then, this angle, this one equals this. Then, because we know the BC equals 6, AB also equals 6. So then we use Pascal's theorem, we can get AC will equals 6 times root 2, right? Because this one equals this. So that means this AC will be the root 2 times 6. So then we can get OC will be half of this. That will be 3 root 2. And OA also will be 3 root 2. So then that means this 3 will equal, and they also equal CD. They give you CD equals 3 root 2. So that means these 3 sides are equal. That means this OCD is a equilateral triangle, right? Then, now let's say they ask you, where is that? Ask you, A, where is the center? That's on the middle point. It's the same middle point of hypotenuse AC. B, what is the radius of the circle? We already got this one, equals 3 root 2. C, what kind of triangle OCD? This is an equilateral triangle. Then D, what are the angles in OAD? OAD. What are the angles in this one? Because this one is 60 degrees. Because this one is an equilateral triangle. So that means this angle equals 120 degrees. And OA equals OD. So OAD is an isosceles triangle. So then that means this angle equals 30 degrees. This also equals 30 degrees, right? Then now they ask you what is the angle, what are the angles in OAD and what is the CDA? CDA also will be a right angle because AC is because this one is 60 degrees. You already got this equilateral triangle. This one is 30. 60 plus 30, that's 90 degrees. Then E, find the area of triangle, area of quadrilateral ABCD. Find the area of ABCD. It's very easy, right? You separate this one's 2 right triangle. So calculate the area of each right triangle. For this one, that will be 6 times 6, then divided by 2. This is the area of triangle ABC. Then the area of triangle of ACD, that's equals, say, CD, that's 3 root 2. Then what is AD? Because hypotenuse, that's still 6 root 2. Use this one square minus this one. So that will be, say, actually this one, because this one's 30 degrees, right? This AD will equals root 3 over 2 times AC. AC, that's 6 root 2. So that means this one equals 3 root 6. So AD equals 3 root 6 times 3 root 2. So you got a 9 root 12. Then divided by 2. So got this one, that will be take a 2 out. That will be 9 root 3. This is the area of triangle ACD. Then you add add 18. That's for triangle of ABC. Then you got 18 plus 9 root 3. This is the area of quadrilateral ABCD, right? So time is up. We can stop here. Your homework, that will be all the exercise problems behind these two sections.